So hello everyone, welcome back to the Simply Game. So in this tutorial, crude oil is processed in a fractionation facility to produce naphtha, kerosene, diesel, atmospheric gas oil and atmospheric residue products. So preheated crude is fed to a free-flash drum where vapor are separated from the liquids which are heated in a furnace. The pre-flash vapor bypass the furnace and are recombined with the hot crude from the furnace, and the combined steam is then fed to the atmospheric crude column for fractionation. So let's start our videos. So in the first step we are going to change the unit of the system. So first go to the file, then go to the options, go to the unit of measure and go to the field and click copy. So here we get a new unit set, name is new user 2. So you can change the name to field density. Okay, enter. Now these are the units for the field density. So first we are going to change the unit for the standard density. So go to the standard density and change the unit to API 60. And next we are going to change the unit for mass density. So this is mass density, change to the API. Okay, change the mole flow unit to the, okay, it's already in MB per hour. So our unit set is already set. So we change the unit for the mass density and for the standard density, click OK. So now we are going to add the component list, click on add. Okay, so our component is H2O, C3, IC4, NC4, IC5 and NC5. So first we add C3. So C3 is propane, add. Next we are adding IC4, then NC4, then IC5, then NC5, and at the end we are adding H2O. So click add. So these are our component list. Okay, so next we are going to add the fluid package. Click on fluid package. For this tutorial we are going to use Ping Robinson as a fluid package. So click on the Ping Robinson and the fluid package is selected. Now our next task is to create and add the hypo components to the component list. In this example we will characterize the oil, which is petroleum fluid, using the given assay data to create the hypo components. So first click on the oil manager tab. So this is the oil manager tab. Go to the input assay. Okay, now click on the add. So this is the, so we are defining the assay. Okay, so when the property view for a new essay is open for the first time, the property view contains minimal information depending on the essay data type we choose. So the property view is modified appropriately. For this example, the essay is defined based on TBP data. So from the essay data type drop list, select TBP. Okay, now it will look like this. Now from the light and drop down list, select input composition. Now in the input data group, select light ends. Okay, now click in the composition cell for ibutane. Composition cell for ibutane, type 0.19 and press enter. So you are automatically advanced down one cell to the n-butane. Okay, and the remaining values will be like, for n-butane it is 0.11, for n-pentane it is 0.37, and for i-pentane 0.37, and for n-pentane it is 0.46. Okay, now from the bulk properties drop down list, select used a new radio button labeled bulk propose. So select used. So a new radio button which is bulk properties appear in the input data group. Now from the molecular weight curve drop down list, select dependent. Now here you can see molecular weight. From the density curve and viscosity curve drop down list, select independent is the curve type. So from both we are going to select independent. Okay, now we are going to enter the data. So first select the bulk properties. Okay, now click in the molecular weight cell in the table and type 300. Okay, so the standard density value will be 48.75 API. 48.75. Okay, now don't change that values of temperature. Now click the calculation default tab, scroll it. This is the calculation default tab, selected. Okay, so in the extrapolation method groups, select Lagrange for each method using the drop down. So select Lagrange for each method. Okay, now return to the input data, select the distillation radio button. So from the assay basic drop down list, select liquid volume. Okay, now click the edit assay button. Now type 0 in the first and press enter, and type 80 in the temperature. So remaining values will be like this. So these are the value for SA, percentage and temperature. Enter all these values and click OK. Now select the molecular weight, click on edit assay, and again we have to enter the values for molecular weight. So sorry, in the previous input data table for the distillation column I make a mistake. I forgot the values for the 10 percentage. So this is the new values. Click on OK. Now go to the molecular weight and click on edit essay. Now we are going to add the values for the molecular weight. Now click OK. Now select the density radio button, click on edit essay. So now we are going to enter the values for the density. So these are the values for the density data. Click on OK. Now select the viscosity one, click on edit. Now we are going to add the values for the density, for the viscosity. Click OK. Now select the viscosity 2, click the edit essay, add the values. Click OK. Now break down and click on the calculate. So essay is calculated. Now go to the working curves. You can see the values for the mole, cumulative mole, NBP, molecular weight, mass, density, viscosity and viscosity zone. And in the plot you can see the plot liquid temperature versus liquid volume percentage. So now we are going to cut the essays. Okay, so go to the output blend, click on add. So there is only one essay, so select it, click on add. So it is already selected at auto cut. So here you can see it is showing blend was calculated. Now click on the tables. So these components could be used in the simulation. So here you can see all the values for component name and all. Now return to the data tab. So from the cut option selection drop down list, select user range. Okay, so in the standard cut point, enter 100. In the starting cut point, enter 100 degree Fahrenheit. So this is the starting point for the first range. The same values as the HYSYS default are used for the other component range. And in the cut end point T column in the table, click on the top cell label empty and enter the value 800. Click enter and In the number of cuts, enter 28, click enter. In the next cut endpoint, put 1200, and in the number of cuts is 8, and the next endpoint is 1400, and the number of cut is 2. Now click on the submit. So the again blend values calculated. Go to the tables, you can see the new blend values. So okay, now viewing the oil distribution. So to view the distribution data, select oil distribution from the table type drop down list, oil distribution. Now you can see this fraction can be used to estimate the product flow rates for the fractionation column. So for example, the kerosene liquid volume fraction is 0.129. Okay, let's assume with 10,000 bbl per day of crude feeding the tower. So the kerosene production is expected as 10,000 multiplied by 0.129, which is 12,900, or roughly 13,000 barrel per days. So now we are going to installing the oil. Go to the oil manager, click on the install oil. Now in the stream name column, click in the top blank, type the name preheated. So in the stream name, type preheat crude. Then press enter. Now click on install. So this is installed. Okay, now we are ready to enter the simulation. So simulation we are going to do in the next video. Till that, learn Aspen. See you in the next video.